Welcome, class, to the 7172 review. In number 1, we're asked to find a polynomial function that models these data. So the first thing we want to do is figure out what degree this polynomial is. So what we do is we find the differences in the y's as you move down the column. As you move across the row, I should say. 16 to 14 is a difference of -2. 14 to 6 is a difference of -8. 6 to -8 is a difference of -14. -8 to -28 is a difference of -20, and -28 to -54 is a difference of -26. So we can see that these differences are not consistent, therefore it's not degree 1. So we do the process over again with the differences. What are these changing by? To get from -2 to -8 is a difference of -6. From -8 to -14 is a difference of -6, -6, -6. So we found a common difference at the second level, making the degree of the equation 2. So we know that the degree is 2. For the second portion of this problem, they want us to find an equation and use matrices to solve. So they want us to find the polynomial function that models these data. To do this, what you want to do is you want to pick out 3 points on the in the table, and you want to use those. You want to use those as your guide points. See, we have y equals ax squared plus bx plus c as our general equation that's going to model the data. What we don't know are the a, b, and c values that will work here. So a, b, and c. So what we'll do is we'll pick 3 points. 1, 16, 2, 14, and 3, 6 to find out what the equation is going to be. Alright, so what we're going to do is we're going to go across the equation y equals ax squared plus bx plus c, and we're going to substitute the values from these 3 points. If I use the point 1, 16, 16 is the y, a is unknown, x is 1 squared plus b times 1 plus c. A, b, and c still stand. Those are the 3 variables we're looking for. X was replaced by 1, y was replaced by 16. We're going to do the same for the next point. 14 is going to replace y. 2 is going to replace x. A, b, and c are unknown. In the third equation, 3 is going to replace x. 6 is going to replace y. And we're going to solve for a, b, and c using matrices. To use matrices, what you want to do is make your first matrix a 3 by 3, and that's going to be called the A matrix. The values are going to come from the coefficients in front of A, B, and C. A has a coefficient of 1 because 1 squared is 1. B has a coefficient of 1, and so does C, even though you don't see it. All of these C's can be understood to be 1C. So the first row in matrix A is going to be 1, 1, 1. The second row will be 2 squared, or 4, 2, and 1. And the third will be 3 squared, which is 9, 3, and 1. That's our A matrix that we're going to put into the calculator. Our B matrix will be a 3 by 1, and it's going to come from the 3 y values that we used, 16, 14, and 6. By entering these 2 matrices into your calculator and using A inverse B, it should tell you that y equals -3x squared plus, I believe, 7x plus 12. Let's double check those. You can see here in this matrix, I have 1, 1, 1 across the row for matrix A. I have 9, 3, and 1 going across row 2, so I want to change that to 4, 2, and 1. And then 9, 3, and 1 should be the third row of matrix A. We go back to matrix and then go over to edit 2, and we're going to change this 3 by 1 matrix to 16, 14, and 6. Go to a blank screen, quit, and type in second matrix A. The inverse key is the one that says x to the negative 1 right here. Then matrix B and hit enter. And there we go. Negative 3 is A, 7 is B, 7x, and 12 is C. This parabola will go through all of the points on that table. One way to check it would be to plug it into y equals and make sure that it produces all of these points on the table.